mistakes, because without that it wouldn't have much value, right? So some disclaimer, I did most of the mistakes myself. It's not like I'm going around and criticizing everybody and just saying, you're doing it wrong, you're doing it wrong. I experienced it myself, and I hit hard the walls that I will be showing you, and so that's why I try to help you out and just give you some starting points so you don't have to repeat my mistakes all over again. What I show you is not a prescription, it's just a suggestion. So if you don't want to do it this way, or if you have objections, just tell me. It's nice to talk about how people do it and how we write our code and see different experiences, because I am myself mostly developer. So I don't do, operation validation, I don't validate environments because I don't have any environment except for a few hosts where I put my Docker images and so on. So I have different concerns, but on the other hand, I use testing every day, and I saw quite a few code bases during multiple projects where the tests were mostly considered like a drawback. So let's just skip the test, do the functionality, and then we deployed and then nothing worked. So yeah, that's a downside. And I will also try to show you the actionable items first, so you can take the action and do some changes in your code base without needing to change too much, without thinking about how we should plan this out, about the abstract stuff. So just small actionable items that you can do yourself. So first example, that's my favorite examples, and that's a test that never fails. That's like a manager's dream. Like you have a test, you have some code, it's always green, never fails. Whatever you do, you have great code coverage because it's running some code, but it will never fail. So if you look at this, you can see that we have this try catch, and if you remember from the previous talk, assertions are just exceptions and ifs. So if we catch the exception, then no exception will ever propagate to the testing framework. It will always be green. It would be also green if we didn't put anything inside of the test case, but then we wouldn't get the code coverage. So this is how you shouldn't be doing it, because this is giving you false sense of security. You have something that's running, something that's reporting, okay, this works, this works, this works, this works. And you can take it and you can deploy it to production, and then you realize, okay, nothing works. So don't do it. But why I have this example is because quite often people miss the detail that assertions are exceptions. So they do stuff like this. And it's not, administrators that are trying to test. This actually came as a part of a developer homework for an interview for a senior job. So yeah, probably he never wrote tests before. Maybe, or maybe he just attempted something and it didn't went very well. But don't repeat the same mistake. This also can show you the structure of this talk. So I will try to show you the problems, I will try to show you the solutions, and some real-life examples. So we already went through this. It's just ifs, try catches. So solutions, just don't catch all exceptions that come from the test. That's quite obvious. If you have assertions that you need to wrap somehow to adapt the message, then just don't use the assertion. Write your own. And I did that, and you can find some info on the internet, for example on this Matthias Busson's blog, where you can register your own assertions into Pester, so then you can get should, dash, whatever you want. Or you can write your own assertions just by writing a function that has an if, an exception in it. So if the keywords that you get from Pester are not enough for you, they are not expressive enough for the domain where you code, then just do it your way. It's not very difficult. So now first real problem, non-descriptive test names, and I love this GIF. The girl is like, what? And that's usually me when I come to code base where they have tests, because the tests are named like test 1, do something, fails, that's great, test name, fails, okay. Runs correctly is even better. And then we get into the realm of, something quite believable, like negative values, positive values. You kind of can guess what the person meant, but then you also have to guess what the results should have been. So they tell you what they put in, but they don't tell you what they want to take out. An empty file, wrong file, same realm. Then we have has error, returns message, that's awesome. And add 1 and 2, but then do what? And delete locked file. Okay, yeah, almost there. So the problems here, you cannot really tell what the test is doing just by reading it, and that's what you usually have. You run a ton of tests on your build server, some of them fails, you look at it and it says test 1. Then ideally it says I expected true but got false, and you're like, okay, yeah. So let's download the code, debug it, try to replicate it, and so on. And that really sucks, because then you don't know what happened. So it's really hard for you to overview what failed. And if you do this over, in your environment validation over servers, then you cannot be really sure if anything wasn't changed when you run the test again. You don't get repeatable tests, and it's really hard for you to know what's happening. So then you will start accepting, like, some of the tests sometimes fail. Okay, yeah. Do you know the reason? No. Because it was false and it should have been true. Yeah. So to fix it, give it the input and give it the expected output. So tell me the intent of the test. Like, given 1 and 5, it returns 6. From that, I can guess you are writing an addition function, like the common example of testing. Or this one, given a valid username and password, it logs the user in. Yeah, that's what should happen. If you just say, given a valid username and password, and then nothing, how should we know what we're doing? The last one is the most interesting from those. That's using the test cases that we already talked about, and this is really useful if you have like test cases, multiple same tests, so you can expand the values. And I will get to it later, but you can also use this PPoSh string. That's a new feature in Pester where you can really specify your intent, and if it fails, you will also get it in the assertion message. So, solutions. Your test names can include spaces, they can include special characters, they can include emojis, whatever you want. So use this power. You have it in PowerShell, and it's great for you. It's great for the test base. You can really read what's happening. In C# we don't have this, and I really regret it. In F# they have it, but we don't. So include both what you're testing and the outcome that you expect, because then everybody can read it and they can understand what's happening. And if you can, just set some project or team-wide a way of writing the test names, because then you have something to rely on, and then you have something to agree on. So everybody can go back. If somebody from the team leaves, then you can just say, okay, this is how we write tests, and everything will be great. Second problem, unreadable tests. So when I inherited my first code base, it had tests like this. It was written in C#, but there was probably a few thousands of the tests like this. And can you guess what it does? Like, even better would be returns message, or positive values, negative values maybe. So I couldn't make any sense of it. It just says, set up test case 1, assert test 1 passed. And I was like, okay. I started digging in the code, and there was this huge inheritance structure of the tests, and they shared the data, and everything was so complex. So I asked the people who already were on the team, and they just said, yeah, the guy who left like 2 years ago, he wrote the tests. Okay, so what do you do with them? Well, if they fail, we fix them. How do you fix them? We don't know. Usually it happens somehow. Okay, what do the tests mean? We don't know. Well, how is it helping you? We don't know. So we had huge code coverage. We had half of the program tested with those tests, but no one knew what they do, and nobody was willing to investigate because it was so complex, and it was totally the opposite of what we want in the tests. So this code has problem. We have no intent in the code. Nobody knows what it means. The code is too dry. So dry means don't repeat yourself. That's something that programmers apply a lot, but you shouldn't be applying it to tests. Because if you repeat code, then it becomes common. If something becomes common, then multiple things depend on it. If you change it, then multiple tests can change. And who says that if you're doing this thing here, you also want to change it in here? And the problem with shared stuff is that it's the first thing where people add new items. So if you have a list of items that you share between tests, then everybody on the team has to understand, if we change this, it will change all the tests that we have. So it's better to just not share it. But if you do share it, then make sure everybody understands that if you change it, it will affect all the tests that you have. Because it's the first instinct of every junior, just looking for the shared items, common library, common function, common file, just to add the items in it, because they're already there, so it's much easier to just put it in the list of items. And the biggest problem with this is that your tests probably won't fail right away if you add the items, so it will just grow and grow and grow, and then in the end you will end up with a set of data where you have multiple dependencies that are hidden, and you just don't know what's happening. So if you do next step, it will start failing, and then you just need to backtrack to the original stuff and so on. It gets really complicated. So just extract the data for each test, and you're golden. Yeah, so solutions. Strive for readability. So reuse the pieces of code inside of your test. So don't be afraid of repeating yourself. Hide the generic stuff that you have into helper functions, but don't hide the data. So if you hide the data, they will become common, you will start expanding them, and you don't want to do that. And if you have these helper functions, I will show you an example in a second, don't add parameters that you don't need. Because if you do that, it will be the same problem as with the common data. If you give me a function that says log user in, then I will probably use it to log in this user, that user, that user, that user. When there is new user, I will just use it again. But if you give me a function that says login admin, it will only log in the admin. So I know exactly what I can use in the function, what it will do, and we don't depend on setup in the database, setup in the code, and so on. So yeah. So this is an example where I apply the damp principle, like, yeah, repeat yourself. And this is something that's only set up for my test code, so the first setup part. And you can see that I'm repeating quite a lot of data, and the data is only specific to my test. So this is maybe too much repetition. If I have hundreds of tests, and I will repeat this in each one of them, and it's just data for the testing, then it will become very difficult to refactor it, a lot of duplication, and so on. So I would probably make it damp just right, like this, where I hide the setup. I have this very specific function that's only for testing. It can only give me a session of an admin to my test environment. And then I have this specific data that are specific for this one test. So I don't want to hide that. Let me just highlight it on the screen. So this is what I don't want to hide, because that's only for the one test. And if I share it somewhere, it will become changed. I don't want that. And then this is the actual thing that I'm doing. So for me, this test would be dumb enough. So I can still tell the intent of what should be happening. So in here we are calculating the average of the numbers somewhere in the cloud. But I see what the numbers are, but I don't see exactly how I'm connecting to the testing environment. And another tip in here is to explicitly use those AAA comments. It might sound silly, but especially in more complex tests, like for environment validation, you have these small pieces of functionality that you will then take and reuse them in a different test. So if you call out what you are actually doing, so this first part, the arrange, would be the setup. And here I might probably use some other function that I already tested somewhere else. And without this command, I wouldn't really know if I'm testing this another function or if I'm testing this get DeepMind average. And then I have this assert. So for me, if I get into this habit of putting the free comments in there, I can immediately see what's being tested. So I go here, see, okay, actually should be expected, that's pretty usual. Then I have this act part that actually tells me what I'm testing inside of this test. And then I have this arrange, which is the boring setup that I need to do in order to make sure that the test have any chance of passing. And if you multiply this and the test becomes like 50 lines of test code that just, sets up database, puts some users in it, puts some roles on them, and so on, and then it just tests. If I try to delete this admin by the user account, it will fail. Then you can really see why those comments are important, because you can just say, okay, this one line is what I'm looking for, and all the other fluff on the top is just the setup. And then we have this new PPoSh parameter that all the assertions have, and this also helps you to capture the intent of what you're doing. So for example, in here, I have this create user function that I created. I have this get user function that I'm also testing somewhere here. And if I didn't have the AAA commands, I wouldn't really be sure where I'm testing and what I'm doing. And then I have this assertion that's somewhere in the middle of the test, which normally wouldn't make really much sense. But here we are using the assertion to make sure that the user is actually created. Because if the user wasn't created, then this part would pass. And so without this setup, the rest of the test doesn't make any sense. So if we don't have any user, we cannot delete it, and we cannot get him back from the database. So use this because to capture your intent, and if this one fails, to tell explicitly, this assertion is here to make sure that the test can be carried out. So because then on the build server, you will see it, and you will know it's not my production code that's broken, it's the test setup that's broken. Does it make sense? Yeah? Questions?
Can it be built into some sort of ladder of workflow of assertions? I mean, if we depend on the multiple systems or multiple values from as of the setup on a range step, can we have some sort of complex ladder or workflows of
like a structure of assertions? Yeah, not really.
Sorry, can you repeat the question?
I can repeat the question. So the question was, if we have a complex setup, can we use this to make complex assertion that will probably only fail when some of the systems fail, right?
Yeah.
So no, the first assertion always fails the whole test, but what you can do is that you save the intermediate results, for example, into an object, or some list of booleans, and then you say in the output message, like, I expected this system to run, this system to run, this system to run, but two of them didn't run. But this would probably be the place where you would want your own assertion, that you can give like a list of callbacks, list of names for the callbacks, and then you execute each one of them. And if one of them fails, then you just report the whole message and you just say this system didn't work. So yeah, this is just one check that we can do. But I have similar concept in the framework or in the library that I was writing, and I call it compound assertion, where I run each one of them and then I report the result. So if any of them fails, I will just report all the failures that I got, not just the first one. Any other question? No? Okay, so let's go on. Unreadable test cases. This one I actually did quite recently. So the test cases we already went through, so just a reminder, we have an int block with the name, we have this tokens that we can expand, and then we have some test cases, and then we can reuse the test body to just carry out the test. So if we apply this, we just say, okay, awesome, we have this one body, and we can just put the edge cases on it till it breaks, and then we get something like this. Which is pretty ugly, and is actually much smaller than what I have in the real code. But can anyone spot something odd? Like something that doesn't look quite right? So let me just point it out for you. This case. The one with the false and false compared returns true. That's not right, yeah? Because any non-empty string in PowerShell will be converted to true. And if you compare true to false, it will be false. So that's something weird that's going on. And again, this is the same idea, share data that become bigger and bigger until you stop understanding what's happening because you lost the intent along the way. So problems, test cases grow until no one knows what's going on. Solutions, split it either into more tests with the same body and add the intent to it. That's my favorite one. You just put it into the it and I will show you the example in a moment. Or you can add the because string into each test case. This is useful if you have multiple different tests and multiple edge cases, like this is null and this shouldn't be accepting the input. And the first one is useful if you have multiple groups of similar input that you want to put into one test. And the last one is just split the test cases into groups and put comments over it. So when you get a junior on your project, you can task him with fixing it the right way. So this is how I would fix it. So the first one says, given two values left and right that are the same, it returns true. That's what we expect. That's how PowerShell works. And this one is the one that I called out. And that's given two values left and right that are different but are special case that's fixed, it returns true. So this is coming from my assert module where I wanted to do like equivalency. And if I get string that says false, I want it to be converted to boolean false. So I had to explicitly fix it to make sure that if people get the JSON object from the web that has false in it and they convert it to a different object and then I compare them, that I get the correct result, the result that people who are not that familiar with PowerShell would expect. Yeah, so if you then review this code and you will add more cases, then you won't get lost in it because it tries to capture all the intent that was behind writing test cases. The next one, too many assertions. Again, a case of losing the intent along the way. So this is something that I called assertion roulette. As I said, first assertion to fail will fail the test. So if this object has name that said something than Jakub, then we will fail. And we will fail here and it will say expected Jakub but got something else. So we fix it, we run it again, and it fails at this line. Okay, we fix it, we run it again, it fails at this line, and then we fix it and we run it again and it doesn't fail anymore, so it's fixed. But if we do this and we have like 10 or 15 different tests pointing at the same feature and it starts breaking somewhere in the future because somebody changed the code, then each of those can fail. And as we start fixing the problem again, then different assertions will start to fail, and multiply it by 50 tests pointing at the same function, maybe failing in multiple different functions because they depend on itself. And then you look at the build result and you have no idea what's the problem. Like you cannot really guess what you should fix in order to fix the problem. And so you have to go into debug mode, you have to go through your code, you have to run on the environment and so on. And you don't want to really do that. So yeah, I would say it's seemingly random results as we progress to fix the bug. So one solution would be write more tests. So some people suggested that if we write a pester test, then we should set up on the top and then for every assertion we should write a different it, which is a good idea, but for me it doesn't really scale that well, because if I have an object that has 20 properties, I don't want to write 20 its and just say testing the property 1, testing the property 2, testing the property 3 and just repeat it. And then I go and I add new property and forget to update the test, so I don't test it anymore and it's really difficult to maintain. So I try to write this assert module where I have object equivalence, where I can take one object, another object, and just say compare them. And if they're different, it will just tell me on the right side, I had a collection with 5 items, 1, 2, 3, 4, 5, and on the left side, the property doesn't exist. And I will get this summary for all the properties that I have on the object, so I don't get only partial information on the failure, I get everything. And that saves me a lot of time, and it's also really useful for complement operations. So if you have like complement operation would be taking a string, reversing it again, and then you should get the original string. Or you can take an object from a server, updating it, putting it on the server, getting it back, updating it back, and so on. So what you post, you should get back. And if you apply this, then comparing the whole object at the same time really gives you like a big coverage of a lot of features. Like if I get an object from the server and post it back, and during the update I don't update anything and still get the same object, then I didn't forget to copy any property from anywhere. So for this, it's really awesome. If you want to help me out develop it, then you can just use the module that's linked in here. And there's also this other concept of the compiled assertions. That's what I talked about with you before. You can put as many assertions as you want into a block, and then it will try all of them and give you the result at the end, so you don't lose any information along the way. So this is the first one, using more tests. This is the next one. This is how the equivalence would work. So we would take the whole object, we would get this whole object from the real function, and then we would just compare them. And if some properties are missing or they are different, it will tell us what's happening, even if like inner property is missing or an array is missing an item and so on. So check it out. If it works for you, then let me know.
Basically just ruined all my tests.
Did I?
With this, yeah, I can replace like 300 lines of code with 10.
See, that's why I wrote it, because I don't want to write those 300 lines of code. And it's heavily influenced by Fluent assertions, which is awesome library for C#. So yeah, and this is the concept for combined assertions. Pretty much we could plug it into Pester and just add a switch that would say should be, and some switch that would tell it like don't fail just yet, fail at the end. But I never got further than the concept. So if somebody wants to implement it or finds it useful, we can finish it up. Okay. So now the most controversial point of this presentation. Do not use should throw. So who here has experience with using should not throw and really likes to use it? No one? Okay, that sucks.
No, you are looking at this from the developer perspective, and I can tell you that no one from like 20 people which I meet during my work, they write some code in PowerShell, but they never heard about throwing
Okay.
an exception or something like that.
Okay, that's interesting.
Yeah, that's the way how the admins do their job.
How about error action stop?
Maybe 2 persons.
Okay, it's interesting. Let's give it up. No. So normally it's very controversial, never mind. So should not throw is one of the assertions we have in Pester, and it's like negation of throwing. So if you get an exception, you should stop at it, and we use it for catching edge cases. So you just say, I have a parameter, and if I provide a null value to a parameter that should have some value, I will throw an exception, or I will terminate the run somehow. This way I will let the user know that something wrong happened, and he can fix his code, or he can react to the exception. Or for example, you're trying to delete a file that doesn't exist. Same idea. And so what people usually do is that they write this kind of function, well, not especially add number, but some complex function, and then they wrap it in should not throw, and they basically just say, okay, this should run, and not throw. But what's the result? Like, what should happen? Do I turn the switch on and the light is on? Or do I just turn the switch on and something happens? So every line of your code is should not throw, because if the code fails, that's why we have the testing framework in there, to catch the exception and fail the test. So if you add this, you're pretty much just adding the information that it should do the thing that it normally does. And the problem with this is that it makes your test look complete, because if you have a test, it should have some assertions, most likely, because you either want to test an action that should happen, like turning the light on, or a value that you get, like the user from some source. And if you don't get that, then you don't really usually run code just to do something and don't give you any effect or any value. You just don't run it for it to run. There was this objection when I was talking about it at the PowerShell Conf EU, and that was, how is that called? Test module manifest.
Yeah.
So test module manifest function, if you give it a valid manifest, it produces nothing. And if you give it invalid manifest, it throws an exception, which is really weird structure of a function, because then you don't know if you called it or not. So if you called it with a correct manifest, it won't return anything, and if you don't call it at all, it doesn't return anything at all. So it would be better if it gave you true or false, or if you gave it an error object that would say this is what's wrong with your manifest, and if that object is empty, or the collection of errors is empty, then your manifest was correct. So this is kind of the same thing, and if you start adding stuff like this where you just assert so nothing failed, then you never know if you actually called the code or not. So then you steer away from the pure functions and it just mangles your code. So if you don't use should not throw, then you're doing the right thing, because the test should actually look like this. We add two numbers and we expect to get some result. We expect to get 20 because we are testing the output value. Or if we were testing the effect, we would be testing assert mock called with something, or maybe you say delete a file. So you create a file, you call your function to delete the file, then you check if the file was actually deleted. That would be an effect that would be coming from this function, but not we called delete a file and it didn't fail. All right. And then the last one on assertions, not failing in assertion. So this is part of like TDD approach, and I don't want to go very deep into that. But when you're writing a test, you are writing it for the assertion. So the assertion is what's testing the important part, what's testing the effect or the value that you got back that tells you this is working correctly. And so if the test starts failing, you should really make sure it fails in the assertion, because that's what you are interested in. If you, let's go back here. Well, no, not very clever, but if we have this add number and we didn't have the assertion, then we don't know what we're testing. And if we have the assertion but it throws from the inside of the add number, then we are not really testing if it adds the number correctly. We just see it fail from somewhere. And so we cannot immediately start fixing the problem because we didn't detect that our code, that our test code is detecting the right problem. So always see your test fails inside of the assertions, because otherwise you have just some code that fails, and you don't want to have that. You want to see that you're testing the right thing. Yeah, conditions and tests. I would like to rest as well. So those are mainly coming from the times when people started writing environment validation tests, and the environment validation tests usually were just polluted with ifs and for eaches and everything, and then you pretty much had complex code, and the test code was really complex and you didn't really know if it's executing correctly. So just don't put logic in your test code, because then you don't know if it's executing correctly. That's the whole point. So if I do it like this, and this is actually code that's inside of Pester test base, so don't call me out on that, but it's not a good way to do, good thing to do. And here we are just not running the test if we are on PowerShell 5, or here is a conditional setup that says if we don't have any DB connection, then we won't be creating the user. But if we don't create the user, then this will probably fail. So the update user will fail. And it won't fail because the update user is broken. It will fail because the setup is broken. And if that happens, we want to fail immediately. So the problems here are that we have tests that contain untested logic, which makes them complex, and also we don't fail fast if the test cannot set up itself. So if we look at scheme, this is how our tests should look like. No conditions in them, no loops, nothing like that. And this is the complex code that we're writing. Because there is this rule, the more tests you have, the more general your code should be, but the tests should still be very simple. So remember the elephant, focus on this, and just write tests that say, it's gray, it's big, it has 4 legs, it has invisible tail, it has black eyes. And then based on those rules, you write the complex code that has to surpass all of those tests. But the tests are still really, really simple. You might not get a perfect picture of an elephant, but the picture of the elephant will be good enough to pass your test. And that's why you are giving your requirements. Solutions, put the conditions in a function and test that. We will expand on that in a minute. And if your test cannot set up itself, just let it fail, because that's what you should do. Your test should fail if the environment is incorrect, but it should fail in the place where it should fail, like where it's failing the setup of the user, not inside of your production code, because then you will get confused about what's actually broken, and that's not what we want. So if we don't create a user here, it will fail on this line. But instead it should fail in here, because creating the user is what failed.
Okay, so the question also on the PSConf was, for example, how to test the environment with that approach. So I'm testing, for example, if the network adapter has setting A, B, C, D, E, if the network adapter is present. So how to write a test, for example, to fail first in the test. So if, for example, a machine does not have the network adapter, the test should fail, even though I don't want to test all those conditions. How to map that?
So you
Testingly.
want to fail the first test and then don't carry out all the other tests. Then you need to add some custom logic. Yeah, because the whole framework is not meant to be environment validation, but you can change it to do that. You can just write the function like this and just say, no, it will be in the solutions. Just wrap the it inside a function like this and test if the network adapter is present inside of that. And if it isn't, then you can fail the describe. Or you can fail an it and set a flag that will say don't run the rest of the test. Or you can set the skip flag on the rest of the tests. But the reason for this is that your tests shouldn't be connected together. So one test should be only concerned with one thing.
So you say I can write functions with Pester-like code inside, like custom function with describe hit block inside?
Yeah. It's just a script block. You can put it wherever you want. So the describe is pretty much just a name and a script block, and then you execute with the ampersand operator the script block. Catch the exception, report it to the screen.
Okay.
So you can wrap it up and you can do it like this. So where's the example? It went away. So this function, invoke on PowerShell 5 or later only, would be an if, and that would execute the script block. So you say if we are on PowerShell 5 or later, then execute the script block that's given to you, and inside of that script block you can have it blocks. And that will then connect to the current instance of Pester and say, okay, are we inside of a describe block? And you will be, because you have described and this function, then the it blocks, and it will just run normally. Then in the same manner, loops and tests. This might or might not be a problem. If you have a loop and you execute it, for example, like this, then if the servers are empty, there won't be any tests. And no tests mean that your test suite will pass. And then the lack of data will just make your whole tests pass. So if something really breaks and you provide no data to your test suite, then you will get 0 results. And if you don't have any other checks in place, like only fail if we run at least 90% of the tests as in the previous run, otherwise fail, then it will pass. And you don't want this if you have something really critical, like run all these audits on those computers, but you made a typo, so you run 0 audits. So what you can do is that you protect the collection with something like this. You pretty much just write a function that you give a collection, and if there are 0 items, you throw an exception. You can put it directly inside of for each, or you can wrap it up like this and then just pass through the item if it's correct.
Yeah, so this will be a solution for empty hash table or array objects, for example.
So if the for each has nothing to iterate over, there will be no it blocks, and you won't run any tests. So if you want to prevent this, you should throw something. Question? No? Oh yeah. So I don't say do it for every collection or do it everywhere all the time, but if you know that you have something that's really critical, then wrap it in something that will make sure that the tests will be there. Now this one, testing environment checks, or not testing environment checks. I wrote this blog post on it. You can go and read it on my blog if you want. But the quick summary is that pretty much environment checks are complex. And they can be complex, for example, like this. This is quite simple, I think. What we do here is that we just make sure that at least 10% of free space is available on my disk. So who can see the typo in there? Just quickly, tell me. No one? Okay, good. Let's just see it in code. So this is the code that we have. Where's the mouse? Not here. No, I'm just trying to look for the cursor, but yeah. There we go. This one. Here we go, yeah. This is the code. If I run it,
DI?
LNGP.
Yeah.
And the last one.
Right.
It will be null. And everything is created in null.
Yeah. So we run it, we can see, okay, my disk has 10% of space because this one was null. And so how do we avoid those kind of mistakes? So we have some code that depends on something that's external, and we can test it, and I can probably test it by what? Filling up my free space, running it again, and make sure that at that one instance it's correct. Or, oh yeah, if I fix the error, I can just run it again and see that it fails. And so if I filled up my space, I found the bug, fixed it, then now I get a failing result. So which one of those is this? Because we don't have any magic eyes, we cannot just open like a big file of code and just spot the typo immediately, as you couldn't do it right now. And so we need a better way of doing this. So what you should do is that you take the body of the function and it's extracted, the body of the it, and extract it into a function that looks like this. And it has all the same code, it has some parameters, well, no parameters, but it has all the same code as in the it. I will just define it. And then your check would look like this. So it would only be a describe and the it would call your function without any parameters, so you cannot make any mistake, you just call it as it is. No typos available at this point. We run it again and it passes, so the typo must still be in there. I think it's a different typo this time, just to make it more fun. But what we can do now is that we can take that function and test it, like the normal way we would test it. Make a mock for the external dependencies, make sure that we are returning the data, and we simulate two different cases. One of them we have 0.1 or something like that space available, so it should pass, and we have no space available, so it should fail, or very little space available, so it should fail. So this would be the first test, and we can see that it should throw an exception, and the second test should pass, and nothing should fail.
The line 84, the expected message, we will need a string out there with the 1, or is it a token from first time?
Let's see.
The 1 is a string concatenate?
Yeah, I think it should be like this.
Okay, so it's just a string.
It's not a token. But you don't have to put the exact message in there. You just need to detect some error. And so if I run it now, I can see that it failed one of the test cases because it cannot detect if I have just 1% of free disk space. And now if I take it and deploy it in production, I won't, because I don't have a successful test run. So I detected the error in my code, and I won't get into a situation where I take my environment validation checks, deploy them in production, and then somebody comes and says, okay, it doesn't work, and you say, okay, what did it do? And then you have failure in production. Instead of that, you can just test it locally. You can detect all the errors. If you improve it, you can just do normal unit testing over your tests, and then you take the functions that will be the environment checks and you deploy them into the production, and you detect all the errors.
So basically I need to redo all my stuff and all the checks put into functions, test the functions first.
Yeah. So you need to write the test for your tests.
Okay. Thank you.
It's not test for your test. That's what we usually start with. Like, people ask, you write tests for your tests, but this is not a test. This is a complex piece of code that's written inside of int block, and it's not testing, or it's testing the environment, but we have no way of validating if it's behaving correctly or not. So that's why we extract it into function. So then the environment checks only act like a run, like a to-do list of something that should be executed, and we execute it against real environment. And then we have a test suite for that environment checks where we make sure that they are correct. Because there we can apply the normal unit testing to say, if we have 10% of free disk space, it should do this. If we have less, we should do this. And this is kind of an extreme example. You can see this is like extremely specific, because sooner or later you will have requirements like, I need 20% of free disk space on this, and in here I need 10% of free disk space. Or I need 10% on C, or 30% on D, and so on, something like that. So this is not very practical. So if you extract it in the function, you can add parameters, but don't add too much. Only add as much as you really need, because with every parameter you are adding a risk of introducing a typo in here. So if I write this parameter incorrectly and I give it some value, then there will be some error, and I can get into the same situation where I have null on one side, some value on the other side. I do something that I don't expect. So yeah, make the parameters as strict as you can, like mandatory. Really have to have the value, have some defaults, and so on. Okay, questions? No? Okay, yeah, problems. This is complex. We can fix it by extracting the bodies to functions, giving it the minimum amount of parameters possible, and you can read the blog post if you want to go again through this example, see all the reasoning that I have around it. But for me, I think this is the way forward, and it also helps you to build like a vocabulary for your tests. So you're just not slapping into some complex code into your test, you're actually saying what should be happening. We did that. I guess we can just skip this. DDD. Yeah, so this would be really long. Anyone here is interested in test-driven development? Or should we skip it as well? Yeah? Okay, everybody's really tired. So the ideal case. Tests should be fast, isolated, repeatable, self-validating, and timely. That means they should run fast so you can detect errors quickly and you don't have to wait around for them to run for half a day, especially for the unit tests. Isolated means that the one test shouldn't depend on other tests, so don't share the data, don't share the infrastructure if you can, or if it's reasonable. Repeatable, just if you run them 20 times, they should fail the same way, 20 times in a row. What's up? So I need to finish under a minute. Self-validating, you shouldn't be taking any action to be able to finish the test, so there should be no pop-ups that you need to go and click. And timely, they should be written on time, but I also saw it as thorough, so they should be deep and they should be examining your code enough, which I think is a better example. Then for me, they should also be small and readable, so you can understand what's happening, because the test should be documentation for your code, at least a bit. And fail with descriptive names. That's why we have the because and all the messages and all the power of the string where you can write whatever you want. So, as a summary, think about the next person that will be working with you on your project, maintaining your project, or that you will be inheriting your project to, because they will love you for great tests. Write a lot of pure functions. We talked about that, like the function that takes the input, returns the output, no side effects, because that makes testing really, really, really simple. And if your tests fail, make sure that you can understand what's happening just by looking at the output. It won't be possible every time, but the more times you get the output from your build server or from your test fail and you don't have to go and debug, you can fix the problem right away, the better your tests are. And that's it. So, questions? No? Everybody wants to do it?
No questions?
Maybe questions at the beer?
Okay, so let me thank you again and close it. Thank you for this.
Well, thank you for inviting me.
It's a huge amount of text to swallow right now, because you made me rewrite all my tests right now. That's not a good thing, but that's a good thing. Thank you. Thank you very much. Thank you all. Thank you on the online. Hi.
I think
I have been there. So yeah, right now we're leaving for some beer, I think. Just let us clean up the room. And I'm not sure whether Kasia mentioned that. We're gonna meet in July. In June there will be no meetup, because it's almost June right now. So let us know what are the topics you'd like to see. We already talked with Jacob that he maybe do some other sessions remotely.
we did. Yeah, we did.
Along the year. So if you want to know anything more about Pesta, just shoot at me and I will chase this guy.
Or just send me a message on Twitter or somewhere, and I can
Will do.
let you know. There are also more stickers, so if you want some, just take them. I have plenty.
Thank you once again. Cheers. Cheers online, guys. The people online are also